modulus of x minus 5. Discuss the continuity of the function f of x. Just question is given like that. Where is the point, at which point we have to discuss the continuity of the given function? Not given. In such a case, we are taking x equal to a is any real number. This is the first point. Next, modulus. It is the special function. Already I said four special kinds of functions, namely one is a modulus function, another is step function, another is a discrete function, another is e power x, e power 1 by x minus e power minus 1 by x divided by e power 1 by x plus e power minus 1 by x. These are four special kinds of functions. In such a case, whenever we are going to discuss the continuity of such four special functions, we go through or apply left hand limit is equal to right hand limit is equal to f of a. If these three values are same, then only it is continuous, otherwise it is not continuous. You can ask me the previous three questions. In three previous questions we didn't follow this definition. Why? Means those are ordinary functions, means polynomial function is ordinary function and rational, it is discovered from the polynomials, therefore it is also rational, means rational function, means it is an ordinary function. That's why we are going through in different way, but this is different case. So therefore we discuss the continuity. We discuss the continuity at x equal to a, that is belongs to capital R. So first, left hand limit at x equal to a, at x equal to a. Therefore, left hand limit is equal to, notation at x equal to a, x tends to a minus f of x. What is the formula? Limit h tends to 0, f of a minus h. Now, limit h tends to 0, f of a minus h. Actually, rough work. F of x is what? Modulus of x minus 5. Then f of a minus h means what? Just instead of x, write a minus h, means modulus of minus 5 same. Instead of x, write a minus h, a minus h. So therefore, it is f of a minus h. So therefore, f of a minus h equal to modulus of a minus h minus 5. So therefore, just put h equal to 0. So modulus of a minus 0 minus 5. It is modulus of a minus 5. Modulus of a minus 5. Modulus of a minus 5. Next, right hand limit at x is equal to a, means it is real number. So right hand limit equal to, notation, limit x tends to a plus f of x. Next, formula, limit h tends to 0, f of a plus h. So therefore, that is equal to limit h tends to 0. Similarly, instead of x we are writing a plus h, then it becomes modulus of a plus h minus 5. So h tends to 0, that is modulus of a plus 0 minus 5, that is equal modulus of a minus 5. So clearly we see that left hand limit is equal to right hand limit. And what is f of a? F of a equal to, f of x equal to modulus of x minus 5. So f of a equal to modulus of a minus 5. So therefore, left hand limit equal to right hand limit equal to f of a. So that follows that f of x, it follows that f of x is continuous at x belongs to any real number. X equal to a belongs to capital R means, what does it mean? X belongs to any real number. Hence the problem. So therefore, already I said one standard form, modulus of f of x is equal to modulus of x minus anything is always continuous at x belongs to capital R. Remember, hence the problem. Is the function fx equal to x if x less than or equal to 1 and f of x equal to 5 if x greater than 1. Already I said this is a discrete function. Means what? Means what? Suppose it is 1 less than or equal to 1 means that in this area it is defined as x. Greater than 1 means here it is a constant function. Of course it is identity function. Identity function. This is constant function. This is constant function. So therefore clearly f of x is a discrete function. Discrete function means in some area it is defined as x, in another area it is different as different 5. This kind of function is called discrete function. In such a case, we are going through or we are applying LHL, RHL, that is equal to f of a. We are finding 3 values because f of x is a discrete function, means special function. Okay, first heading at x equal to 0. Heading at x equal to 0. 0 means 0 is in this area. X equal to 0 is in this area. So therefore here f of x defined as x because x equal to 0, it is less than 1 area. So therefore here f of x is ID function, ID function, identity function or polynomial of degree 1 within bracket of degree 1. So already I said every polynomial function, therefore f of x is continuous since every polynomial function is continuous for all x belongs to capital R. So therefore f of x is also continuous at x equal to 0 because 0 is belongs to capital R. So therefore in first case it is continuous function. Next heading at x equals to 1. At x equal to 1. Already it has given as this is 1. In this area it is x and greater than 1. In this area it is 5. This is x greater than 1 case. This is x less than or equal to 1 case. So therefore clearly f of x is a discrete function. That's why we are going through left hand limit, right hand limit and f of a. So therefore left hand limit at x equal to a. This is the heading. So left hand limit is equal to limit x tends to 1. Instead of A, it is 1. Minus stands for left. So this is f of x. 1 minute. That x less than 1, minus stands for less than. X tends to 1 minus means x less than 1. So formula limit h tends to 0, f of a minus h. This is the formula. Okay. X less than 1. Okay. In this case, when x less than 1, f of x, rough work, f of x is x less than 1. X less than 1 means x. This is x. So what about f of 1 minus h? Instead of x, write 1 minus h. It is nothing but 1 minus h. So therefore, that is equal to limit h tends to 0, f of 1 minus h. So it is 1 minus h, that is equal to 1 minus h 0, that is equal to 1. So therefore, left hand limit equal to 1. Next, right hand limit. Right hand limit at x equal to 1. So notation, right hand limit is equal to limit x tends to a plus, here a equal to 1. So 1 plus f of x. X tends to 1 plus means what? X is greater than 1. X is greater than 1. 1 minute. When x is greater than 1, what is f of x? 5. Here f of x is equal to 5. Then formula limit h tends to 0, f of a plus h. So that is equal to limit h tends to 0. What is f of x? In this case, 5. So what is f of 1 plus h? Means instead of x, write 1 plus h. But there is no x, therefore it is constant for every different values. Okay. So this value is just 5. So therefore, since it is a constant, there is no h to substitute 0. So it is standard 5. So therefore right hand limit equal to 5. Right hand limit equal to 5. So therefore, clearly left hand limit is not equal to, left hand limit 1, right hand limit 5. That is not equal to RHL. Whenever left not equal to right, there is no comparing the value of f of a value. So therefore, left hand limit not equal to right hand limit. Therefore, f of x is not continuous, at x equal to 1. This is the second part. Next, here third one, at x equal to 2. Subheading, at you come here, at x equal to 2. At x equal to 2. 2 means what? It is greater than 1 case. In greater than 1 case, it is just defined as f of x is equal to 5. 5 means it is the constant function. So therefore, but every constant function is continuous at x belongs to any real number. So therefore, f of x is continuous at x equal to 2. So therefore, at x equal to 0, the given function is continuous, and at x equal to 2, the given function is continuous, but at x equal to 1, the function is not continuous. This is the inference. Question. Discuss the continuity of the function f of x equal to modulus of x plus 3 if x less than or equal to minus 3, and minus 2x if x lies between minus 3 to plus 3, and 6x plus 2 if x greater than or equal to 3. Once again, we have two kinds of definitions, namely number one, if limit extends to a, f of x equal to f of a, then it is continuous. Next, number two, left hand limit equal to right hand limit that is equal to f of a, then it is continuous. But this is for ordinary functions, this is for special functions. In special functions, what I said, namely number one, modulus function, number two, step function, number three, discrete function, number four, e power 1 by x minus e power minus 1 by x by e power 1 by x plus e power minus 1 by x, just like that. Now we are in discrete function because minus 3, for example, it is 0. Suppose this is minus 3, this one is plus 3. So less than or equal to minus 3, less than or equal to minus 3 means this area is equal is there. In this area it is defined as mod x plus 3. Next, minus 3 to plus 3 means open interval of minus 3 to plus 3 means this area. In this area it is defined as minus 2x. Later, greater than or equal to 3, it is 6x plus 2. 6x plus 2. This is x greater than this area is x less than or equal to minus 3 area. This is minus 3 less than x less than 3 area. It is x greater than or equal to 3 area. So therefore the function from here to up to infinity, it behaves as modulus of x plus 3. After minus 3, it changes its behavior. After 3, it is changed. Means what? This point minus 3, later plus 3. These are the breaking points. Breaking points. So minus 3 and plus 3 are the breaking points. Therefore, breaking points of f of x are x equal to minus 3 and plus 3. Actually, in the question, discuss the continuity of the function, but points are not given. But we have to discuss the nature of the function at the breaking points only. Breaking points means minus 3 and plus 3. Therefore, thus we are discussing the continuity at x equal to minus 3 and plus 3. Minus 3 and plus 3. Okay. Next. First heading. At x equal to minus 3. This is the heading. Okay. Means instead of a, we are writing minus 3. So left hand limit is equal to limit extends to a. A means minus 3. Actually, notation, limit extends to a minus f of x, that is equal formula, h tends to 0, f of a minus h, just like that. Instead of a, we are writing minus 3. So minus. This minus is different. This minus is different. This minus stands for the direction, left hand side. This minus means it is the value minus 3, point. Minus 3 is a point. So it is nothing but x is less than minus 3. That is the complete meaning. So it is f of x, that is equal to formula limit h tends to 0 f of a minus h. Okay, when x is less than minus 3, this area, in this area function is defined as, we can write here f of x equal to modulus of x plus 3. So what about minus 3 minus h? F of minus 3 minus h equal to, means instead of x it is minus 3 minus h, modulus of minus 3 minus h plus 3. So that is equal to limit h tends to 0, it is modulus of minus 3 minus h plus 3, that is equal modulus of minus 3 minus 0 plus 3, that is equal to modulus of minus 3 plus 3. Modulus of minus 3, 3 plus 3, that is equal to 6. So therefore left hand limit at x equal to minus 3 is 6. Next, okay, we will write here, therefore left hand limit equal to 6. Left hand limit equal to 6. Next, you come here, right hand limit, that is equal to, what is right hand limit? Limit x tends to a plus f of x. This is the notation. What is its formula? Limit h tends to 0, f of a plus h, just like that. Okay. So right hand limit is equal to limit x tends to a is minus 3 plus f of x. So what is the formula? Limit h tends to 0, f of a plus h. So that is equal to, next, here x tends to minus 3 plus means x is greater than minus 3. X is greater than minus 3. Okay, where is x greater than minus 3? Means it is jumped in this area. Greater than minus 3 means this area. So in this area means f of x in this section, in this area, f of x is equal to minus 2x. Then what about f of minus 3 plus h? Minus 2 into minus 3 plus h, that is equal to, on simplification, 6 minus 2h. So therefore limit h tends to 0. What is its value? 6 minus 2h, that is equal 6 minus 2 into h 0. So 6 minus 0, that is equal to 6. So therefore left hand limit equal to right hand limit. Okay, next, and what is f of minus 3 value? F of minus 3 value is equal to minus 3 case, is here. So f of minus 3 means modulus of x is equal to minus 3 plus 3, that is equal to 3 plus 3 also 6. So therefore left hand limit equal to right hand limit, it is also equal to f of minus 3. So therefore f of x is continuous at x equal to minus 3. Okay, next we have to discuss at x equal to 3. Now the heading is at x equal to 3. At x equal to 3. At x equal to 3. Once again, left hand limit at x equal to any point A is left hand limit, that is equal to limit x tends to a minus f of x. You see here, f of x formula, limit h tends to 0, f of a minus h. Next, right hand limit at x equal to a is right hand limit, that is equal to limit x tends to a plus f of x, that is equal to limit h tends to 0 f of a plus h. It is the formula notation meaning. 1 minute. X tends to a minus means that x is less than a. Remember, x tends to a plus means x is greater than a. So here left hand limit. So limit, instead of a we are writing 3. So x tends to 3 minus f of x. Notation. Next formula, limit h tends to 0 f of a minus h. It is the formula. Okay. What does it mean of x tends to 3 minus? It is x is less than 3. X is less than 3. So when x is less than 3, where is x less than 3 area? This one. So in this area, write side by side minus 2x. Okay. Next, what is the value of f of 3 minus h? That is minus 2 into 3 minus h. That is equal minus 6 plus 2h. So therefore, it is limit h tends to 0 minus 6 plus 2h. That is equal minus 6 plus 2 into 0. So minus 6 plus 0, that is minus 6. Therefore, left hand limit is minus 6. Next, at the same point, we are going to find the right hand limit. Right hand limit. Right hand limit. Okay. Notation. Limit x tends to 3 plus. 3 plus. You come here. F of x. F of x. That is equal to limit, that is equal to limit h tends to 0 f of 3 plus h. So x tends to 3 plus means what? X is greater than 3. X is greater than 3. Here rough work. Here means x is greater than 3 case. Here what is f of x? What is f of x? X greater than 3. Where is x greater than 3 case? Here. It is defined as 6x plus 2. 6x plus 2. Next, what is f of 3 plus h? F of 3 plus h. 6 into 3 plus h plus 2. So 9. 3 plus, okay, 18 plus 6h plus 2. So 6h plus 20. So therefore, it is limit h tends to 0, 6h plus 20. So that is equal to 6 into h0 plus 20. That is equal to 0 plus 20. That is equal to 0. So therefore, at x equal to plus 3, left hand limit equal to minus 6. Here minus 6 and right hand limit equal to 20. So therefore both are different. Left hand limit not equal to right hand limit, and we need not to find f of 3 value. That's why we can stop the process. So therefore it follows that f of x is not continuous at x equal to 3. So therefore f of x is continuous at minus 3, but it is not continuous at x equal to 3. Once again you come here. Soon after reading the question or taking the question, you draw the real line like that. So in which area it is defined as so and so, in this area it is defined as so and so, in this area it is defined as so and so. So how many three cases are there? How many cases are there? It is not criteria. For all cases you draw like that and find the breaking points like that. Remember once again, at the breaking points only we are discussing the nature of the given function, means the continuity, whether it is continuous or discontinuous. At the breaking point we discuss there itself, not at other points if it is not given. Okay, if it is given, then particularly at that area, at that point we can discuss the continuity of the given function. So this is the procedure. And another important thing is left hand for y is equal to f of x, and to be understood that a is in its domain. Small a is belongs to the domain of f of x. LHL at x equal to a is limit x tends to left means minus. Minus means x less than a. You must by heart all those things. F of x. It is the notation, meaning, formula. Limit x tends to 0. F of a minus h. Next, RHL at x equal to a. Limit x tends to a plus f of x, meaning x a plus means x greater than a. Formula. Limit h tends to 0. F of a plus h. This is the standard procedure. Next the problem.